Hello students, we are going to see the practical of Kol's method. This is the practical in which we will see that how can we estimate glucose sugar by using Kol's method. There are so many different methods for estimation of sugar. Monosaccharides like glucose, galactose and some disaccharides like lactose and maltose are known as reducing sugar because of the presence of free aldehyde or keto group. They can give so many different reactions like glycoside formation, iodo compound formation, acetylation, osazone formation, interconversion, formation of furfural, and reduction of metal salts. Sugars can be measured by three different methods: oxidation reduction, condensation, and enzymatic measurements. Let us see about oxidation reduction methods. The enediol form of a sugar is highly reactive and easily oxidized. Upon oxidation, carbon chain of carbohydrate is ruptured with the formation of acids of shorter chain length. Several methods are based on oxidation reduction reactions of sugar like Folin-Wu method, Nelson-Somogyi method, Schaefer-Hurstman-Somogyi method, neocuprine color reaction, alkaline ferrocyanide method, and so on. Now about condensation methods. Sugars can react with aromatic compounds and produce colored complexes. These colored complexes can be estimated spectrophotometrically. Glucose and other aldoses can undergo condensation reaction with varieties of aromatic compounds like phenols and primary aromatic amines in the presence of hot acid, and they give colored products. For example, hydroxymethylfurfural is the product formed from glucose in hot, strongly acidic solutions. The aldehyde group of this product condenses with phenols like resorcinol, thymol, anthron, alpha-naphthol, aminophenol, and chloroglucinol. Also with some aromatic amines like O-toluidine, aminophenol to give colored compound. These all colored compounds can be estimated by spectrophotometer. Now the third category of reactions given by carbohydrates, they are enzymatic methods. There are several enzymes which can be used for estimation of glucose, glucose oxidase, hexokinase, acyl phosphate D-glucose 6-phosphotransferase, and glucose dehydrogenase. Out of all these, two very important enzymes are hexokinase and glucose oxidase, which are frequently used in the routine determination of glucose content in body fluids. Now let us see about Cole's method and its principle. Reducing sugars are those that have a free aldehyde or a free keto group. Such sugars undergo tautomerization reaction to form enol salts under alkaline conditions, and these enol salts can work as very powerful reducing agents. Metal ions like copper, bismuth, silver, and FeCN6 can easily be reduced by enediol form of sugar under alkaline conditions. In Colt's method, K3FeCN6 is used as an oxidizing agent. It oxidizes enediol form of glucose and itself get reduced. Glucose can reduce K3FeCN6 to K4FeCN6. Glucose is oxidized to form complex mixture of acids like lactic acid, formic acid, succinic acid, and so on. Methylene blue is here used as an indicator. It is reduced after complete conversion of K3FeCN6 into K4FeCN6 by enediol form of sugar. So, sugars having free keto and aldehyde groups, when heated in alkaline solution, their keto or aldehyde groups are converted to form enediol. This enediol form has more reducing power and reduces K3FeCN6 to K4FeCN6, and sugars are oxidized to complex mixture of acids. The amount of ferricyanide reduced depends upon the concentration of sugar in the given sample. Ferricyanide ion, yellow solution, are reduced to ferrocyanide ion having colorless solution. Potassium ferricyanide solution is treated with alkali and boiled. The mixture is titrated with the sugar solution. When the yellow color has nearly disappeared, a drop of methylene blue is added. The titration is continued until the color is discharged. Both methylene blue and ferricyanide are reduced by sugars in hot alkaline condition. But the indicator methylene blue is not affected until the whole of the ferricyanide has been reduced to ferrocyanide. The endpoint is reached when the solution turns from blue to colorless. Now about requirements of Cole's method. We require 1% K3FeCN6 solution, 2.5 normal NaOH solution, 1% methylene blue solution as an indicator, 1 ml pipette and 10 ml pipette, conical flasks, glass beads, Bunsen burner, wire gauze, tripod, distilled water, and measuring cylinder. Now how to proceed for Cole's method. First of all, two solutions are taken into the flask. Take 20 ml of 1% K3FeCN6 and 5 ml of 2.5 normal NaOH in a flask. Boil the mixture and add a few glass beads to avoid bumping during the boiling of the solution. Now Heating should be arranged in such a way that the mixture begins to boil within 2 minutes. As soon as the mixture boils, the flame can be lowered to avoid excessive boiling. Active boiling should be maintained during the whole of the titration. In the diagram, you can see the entire assembly, which is clearly says that how the arrangement is to be made with the help of burner, tripod, wire gauze, flask, mixture of two solutions in which glass beads are added, and from the top 1 ml pipette is used for dropping the sugar solution. Now add sugar solution, drop twice, and before that fill the 1 ml graduated pipette with sugar solution and add few drops of sugar solution in the boiling mixture at intervals till the color of the ferricyanide changes from dark yellow to faint yellow. Now add 1 to 2 drops of 1% methylene blue when the solution becomes pale yellow. So now the solution is having blue color. Now continue the titration until the blue color of the methylene blue gets disappeared. Now note down the volume of the sugar solution consumed, and this is our pilot reading. Now 3 different pilot readings are taken and average is found out, and it is noted down as capital P in milliliters. Now then after dilution is to be made. Dilute the sugar sample by taking sample amount equal to pilot reading and make the final volume to 10 ml by adding distilled water. Prepare sufficient volume of diluted sample for at least 3 readings. So here we require at least 40 ml of the diluted sugar sample. Now repeat the practical for 3 times and find out the end point where blue color turns to colorless in the mixture. Now decolorization of methylene blue is our end point of the titration, and we will note it down in our book. Then after average of the amount of sugar solution is found out, and it is then after given the name capital X, which is usually in between 9 to 11 ml, and that is our titration reading. Now calculation for Cole's method. There are several formula for different carbohydrates like glucose, lactose, maltose and sucrose. Here we are concerned with the calculation of glucose sugar, and its formula is like this. Reducing sugar milligram per ml is equal to 20.12 plus into bracket 0.035 into x milligram per x ml. Here x is average titration reading. If we want to find out the gram percent of the sugar, it will be having little bit different formula. Reducing sugar gram percent is equal to 20.12 plus 0.035 into x ml upon x milligram upon x ml into 10 upon p into 100 upon 1000. Now here we will take an example for our calculation. Suppose our pilot reading is 1.95 and our titration reading is 10.01 ml. Now putting the value of this reading in the formula, it will be like this: 20.12 plus 0.035 into 10.01 milligram per 10.01 ml. So it will be is equal to 20.2 milligram per 10 ml. But we know that in case of this original sugar solution, we have taken 1.95 ml of the sugar which is consumed during the reaction. So we can write like this, that the 1.95 ml of sugar solution contains 20.2 milligram of sugar, then 1 ml contains how much? So it will be is equal to 20.2 into 1 upon 1.95 milligram per ml. So it will give 10.35 milligram per ml. And if we convert this into gram percent, it will be 1.35 gram percent glucose. Now, there are certain notes to remember, that if the pilot reading is too small, we should dilute the sample appropriately, and pilot reading is taken again and dilution is then after used for the calculation parameter. Non-reducing disaccharides like sucrose require an additional step of hydrolysis for breaking of glycosidic bond between monosaccharide units. When disaccharides are estimated, the formula for calculation is changed. The range of the Coles method is from 1 to 4 milligram per ml. For writing up the conclusion of Coles method, we can write like this: the unknown sample of sugar contains dash gram percent of reducing sugar glucose estimated by Coles method. Thank you very much.